Alright, in this problem we're asked to first factor a quadratic that can be factored and then find the solutions, and then we're also asked to solve a quadratic equation that can't be factored using the quadratic formula. So I have picked two equations out. The first one can be factored and the next one cannot be factored. So let's go ahead and start with our first example here. So 11x squared minus 18x minus 8 equals 0. So the first thing you actually want to look for is if it can be factored, which yes, it can be factored here. This is going to factor as the product of two binomials. We're going to set up two sets of parentheses. 11x squared factors as 11x times x. And then what we're looking for is the factors of negative 8, and the factors that we use are positive 4 and negative 2. Because this creates a situation where the product of the outer terms, negative 22x, plus the product of the inner terms, 4x, is negative 18x, or our middle term. Now we're just going to set this equal to 0. Now if two terms are multiplied together to equal 0, either one term or the other term must equal 0. So we can split this up into two parts. 11x plus 4 equals 0, or x minus 2 equals 0. Now to solving for x in each equation, we subtract 4 from both sides of the first equation. We have 11x equals negative 4. Divide both sides by 11. X equals, let me fix that x, sorry about that. X equals negative 4 11ths. For our second equation, we just add 2 to both sides, and we get x equals 2. So our solution is going to be negative 4 11ths, or 2. Alright, so now let's take a look at a quadratic that cannot be factored. So this cannot be factored. So we're going to use the quadratic formula, which states that q is going to be equal to, actually before I do that, let's first identify our coefficients. So remember that a is going to be the coefficient of your squared term, so a is going to be equal to 2. B is going to be equal to the coefficient of your q term, which in this case is 1, so b equals 1, and c is going to be your constant. Now we can write the quadratic formula, which is q in this case, equals negative b plus or minus the square root of b squared minus 4ac over 2a. So q is going to be equal to negative b, or negative 1, plus or minus the square root. Actually, I'm going to write this a little bit farther down just so we have a little bit more room. So you have q equals negative 1 plus or minus the square root of b squared, which is 1 squared, or 1 minus 4 times a, which is 2, times c, which is negative 12, all over 2a, or 2 times 2, which is 4. Simplifying further, under the radical, we have q equals negative 1 plus or minus the square root of 1 minus 8 times negative 12. And negative 8 times negative 12 is going to give us positive 96. So 1 plus 96 is going to be 97 over 4. And the square root of 97 actually does not break down. So our answer is actually just going to be negative 1 plus or minus root 97 over 4.